Right now, as you're watching this video, something is happening across the universe. Every second, galaxies are moving farther apart, not slowly, faster and faster. And the strangest part? Scientists have absolutely no idea why. Whatever is causing this mysterious force could determine the ultimate fate of everything. Every galaxy, every star, every planet, even you. And if one theory is correct, the ending could be far worse than anyone imagined. In 1929, astronomers made an incredible discovery. The universe wasn't standing still, it was expanding. Every distant galaxy seemed to be moving away from us. Imagine dots drawn on a balloon. As the balloon expands, every dot moves away from every other dot. That's exactly what our universe appears to be doing. At first, scientists thought gravity would eventually slow everything down. It made sense. Gravity pulls things together, so eventually, expansion should start weakening. But then came one of the biggest scientific surprises in history. By the 1990s, astronomers believed they understood the universe's future. The expansion caused by the Big Bang was real. But gravity was everywhere. Every star pulled on every other star. Every galaxy pulled on every other galaxy. The universe was a giant tug of war, and gravity seemed destined to win. The question wasn't if expansion would slow. The question was how much. To find out, scientists looked at something extraordinary: dying stars. More specifically, a type of exploding star called a Type 1a supernova. These explosions are so bright that they can outshine entire galaxies. Astronomers use them like cosmic measuring sticks. If you know how bright something should be, and it appears dimmer than expected, you can estimate how far away it is. It was a clever method, one that would eventually reveal one of the greatest surprises in scientific history. Two independent research teams began studying distant supernova. They expected a routine result, evidence that gravity was gradually slowing the universe's expansion. But when the data arrived, something was wrong. The stars appeared farther away than they should have been. At first, scientists suspected mistakes. Maybe the telescopes were off. Maybe dust in space was distorting the measurements. Maybe the calculations contained hidden errors. So they checked, then checked again and again. The result refused to disappear. The universe wasn't slowing down, it was accelerating. Imagine throwing a baseball into the sky. You expect it to slow down as gravity pulls it back, but instead, the ball speeds up, faster and faster. That's effectively what the universe was doing. Something invisible was overpowering gravity itself, something no one had predicted, something we still don't fully understand today. After discovering that the universe is expanding faster than expected, scientists faced a much bigger problem, because the math didn't just reveal a strange force. It revealed something far more disturbing. Almost everything in the universe is missing. When you look around, it feels like reality is full of matter. Stars, planets, asteroids, gas clouds, entire galaxies. But all of that, everything you can see, is only a tiny fraction of what actually exists. Scientists estimate that all ordinary matter, the kind that makes up atoms, planets, and even us, is less than 5% of the universe. That means if you took everything you've ever seen and everything you've ever touched, it would barely register on the cosmic scale. So, what makes up the rest? The first piece is something called dark matter. We can't see it, we can't touch it, we can't detect it directly, and yet, galaxies behave as if it surrounds them. Without it, galaxies would fly apart, stars would drift away, the universe wouldn't hold its shape. It acts like an invisible skeleton, holding reality together. But here's the problem. We still don't know what it actually is. Not a single particle of dark matter has ever been directly observed. But here's the problem. We still don't know what it actually is. Not a single particle of dark matter has ever been directly observed. If dark matter is holding the universe together, then something else is doing the opposite. A force that pushes everything apart. Dark energy. Unlike dark matter, this force doesn't pull. It expands space itself. Not galaxies moving through space, but space itself, stretching between galaxies. Imagine dots drawn on a rubber sheet. Now stretch the sheet. The dots don't move by themselves, but they still get farther apart. That is the universe. And now we reach the most shocking part. When scientists combine all their measurements, they arrive at a disturbing conclusion. Everything we can see, every star, every galaxy, every black hole, accounts for less than 5% of reality. The rest is something we cannot see, cannot directly measure, and cannot fully explain. About 27% is dark matter. About 68% is dark energy, which means the universe we experience is not the main story. It is the tiny visible surface of something far larger. And this leads to a question that even scientists struggle with. If most of reality is invisible, then what else are we missing? Are we studying the universe, or only the small part of it that we are capable of seeing?